Okay, so welcome to the deep dive where we ditch those boring textbooks and dive headfirst into the real nitty-gritty
Yeah.
of SQL. And today we're going to see it's not just some abstract language, it's actually quietly running a lot of things behind the scenes,
Hmm.
from, like online shopping to like your doctor's records.
Yeah.
We've got a ton of insights that we've pulled from our sources, and think of it like a cheat sheet
Right.
to understanding how SQL gets things done across different industries.
Absolutely.
Mhm.
And I think our mission today really is to sort of uncover that power and versatility of SQL
Yes.
for solving those tangible problems.
Yes, exactly. So we're going to really drill down into very specific examples from different industries,
Yeah.
like e-commerce, healthcare, and finance. We're even going to look at actual SQL queries, and
Mm.
we're going to see what kind of insights they can give us. By the end, you should really have a concrete understanding of how adaptable and how crucial SQL is for tackling all kinds of real-world problems.
Exactly.
Okay, so let's get right to it. What makes an SQL use case like a real-world use case?
Well, a real-world SQL use case is really when we use SQL
Right.
to manage, analyze, and extract meaningful insights
Mm-hmm.
from data that exists in various industries.
Okay.
So think of it as taking that raw data and shaping it into something that can inform decisions,
Yeah.
highlight trends,
Uh-huh.
or directly address a problem.
Okay, so it's not just about like
Okay.
setting up the structure of a database, but like what can you do with that data?
Exactly. It's about putting that data to work
Right.
in a meaningful way.
Right. Okay. Can you give us an example maybe to make this more tangible?
Sure. Let's imagine we're in the world of e-commerce, something we probably all interact with almost daily.
Yeah.
Let's say your favorite online store wants to understand who their biggest fans are.
Okay.
It's their top spending customers.
Okay.
They can get this information with this SQL query.
Okay.
Select customer dough, S amount as total sales. From orders, group by customer, order by total sales, DSC.
Okay, so wow, that
Yeah.
looks like a lot, but let's break it down. So we are selecting the customer ID, and then we're using sum
Right.
to add up all of the purchase amounts, which we're labeling as total sales.
Exactly. And that from orders part
Mm-hmm.
is telling the system where to look for this data
Okay.
in the orders table where all the transactions are stored.
Okay, and then the key part, I think, is that group by customer ID.
Right.
And that's what kind of takes all those individual orders
Yes.
and then lumps them together
Yeah.
under that customer so we get a total for each person.
Precisely. It's like organizing all the receipts by customer before calculating the totals.
Right, okay.
And then that last part, that order by total sales DSE, arranges the list
Okay.
so that your top spender appears at the very top.
Okay, so what's interesting is that this isn't just some arbitrary list of spenders.
Right.
It's actually very useful information.
Exactly.
Ah.
By understanding their top customers, this store can tailor exclusive offers,
Oh, okay.
provide exceptional service,
Right.
and ultimately cultivate loyalty, which leads to more sales.
Wow, so just with a few lines of code,
Yeah.
you can get a lot of strategic information.
Absolutely. It highlights how concise code can unlock valuable business insights.
Yeah, so as our source kind of emphasized the core SQL functions,
Mhm.
like that sum for aggregations, grouping by sorting with order, and then filtering with those are the fundamental tools to drive those data insights.
And it's worth emphasizing, these are not just abstract commands, they're how organizations across all sectors
Uh-huh.
actually engage with their data.
Okay.
These operations are fundamental for spotting trends, identifying crucial patterns,
Okay.
and making decisions that have real-world impact.
Okay, so we've kind of got a good grasp, I think,
Right.
on what makes an SQL use case real world. Let's
Yeah.
explore some common applications across different industries.
Yeah.
Our source highlighted e-commerce, healthcare, and finance. We
Mhm.
kind of already dipped our toes into e-commerce with the top customers example.
Yes.
What are some other typical ways that SQL is used in that sector?
Well, beyond identifying those top spenders,
Yeah.
e-commerce businesses use SQL to understand all sorts of customer behaviors.
Okay.
They often calculate the average order value,
Okay.
which is really key for understanding spending habits
Mm-hmm.
and, the effectiveness of promotions.
Right, so you wouldn't just want to know who's your top spender, but also how much do people typically spend?
Exactly.
Okay.
They also track customer retention rates
Yeah.
by analyzing how many customers return for more purchases over time.
Okay, so how good are you at keeping people coming back?
Exactly.
Okay, now let's switch gears and talk about healthcare.
Okay.
How is SQL making a difference there?
In healthcare, the applications go beyond just business intelligence.
Okay.
They often directly impact patient care and public health.
Okay.
SQL is really the backbone for managing vast amounts of patient data.
Mm-hmm.
It's used to maintain accurate patient records,
Okay.
and it's crucial for generating those vital reports,
Oh,
like
okay.
the frequency of diagnoses, trends, and admissions.
And patient demographics like
Yeah.
age or location.
Yeah, our source even gave this example.
Right.
This query, select diagnosis count as diagnosis count. From patients group by diagnosis, order by diagnosis count, DSC.
Yeah, so this allows hospitals to pinpoint the most common illnesses among their patient population.
Okay.
So that count is just tallying each instance of a diagnosis.
Okay.
And Group by Y diagnosis is neatly organizing those counts for each unique diagnosis.
Okay.
And then we have that order by diagnosis count, DSC, to arrange the results with the most frequent diagnosis at the top.
Okay.
This is incredibly valuable for things like, allocating resources within a hospital,
Right.
informing public health initiatives.
Right. So if you know that a certain disease is becoming more common or maybe less common.
Yeah, and identifying potential emerging health concerns.
Wow. Okay, that's a powerful example.
It really highlights the role of data analysis
Yeah.
in making informed decisions
Okay.
in a critical field like healthcare. Okay, so now let's move on to finance.
Good.
Our source mentioned some key applications like detecting fraud, analyzing account balances and transaction patterns.
Right.
How does SQL contribute to that?
Well, in finance, where speed and accuracy are really critical,
Yeah.
SQL analyzes massive amounts of transaction data,
Uh-huh.
sometimes in real time,
Okay.
to flag patterns that might suggest fraud.
Okay.
This might involve looking for unusually large transactions,
Right.
transactions from unexpected locations,
Uh-huh.
or sudden increases in the frequency of transactions.
Okay.
SQL queries filter and aggregate this data to pinpoint suspicious activities,
Okay.
which can trigger alerts and investigations.
Okay.
Also, analyzing account balances and transaction trends
Uh-huh.
helps financial institutions understand customer behavior, manage risk, and identify customers who might be in financial trouble.
Okay, so it seems like in all these different sectors,
Yeah.
the main idea is you have a huge amount of data
Right.
and you use SQL to kind of sift through it.
Exactly,
Yeah.
and then perform those calculations to extract that information.
It's all about turning that raw data
Right.
into something useful and insightful.
Okay, so we've explored some of the common uses now.
Yes.
Let's look at some of the more sophisticated SQL techniques that our source brought up.
Sure.
We're talking about things like calculating running totals
Yeah.
and maybe more advanced ways to detect fraud.
Right. So while basic aggregations and filtering are the foundation,
Okay.
SQL allows for more intricate analyses.
Uh-huh.
For instance, consider calculating running totals. Imagine a business wants to see how their revenue has grown day by day or week by week.
Okay.
They can do that with a query like this.
Yes.
Select
Yeah.
order date, revenue, SEM revenue over order by order date as running total from orders.
Okay, so
It's a bit more involved.
that's more involved than some of the others.
Yeah.
What's going on there?
So that SEM revenue over order by order date is a window function.
Think of it this way. The SEM revenue part is doing the addition,
Okay.
but the over order by order date is telling SQL to do it cumulatively as it goes through the orders by their date.
Okay.
So for each order, the running total is the sum of that order's revenue plus all the revenue from previous orders.
So it's like a dynamic view of how
That's-
that money is accumulating.
It gives you that step-by-step picture of the revenue growth,
Yeah. Right.
which a simple total just wouldn't show.
Okay. That's really cool.
It's a very powerful technique.
Okay, now let's circle back to that fraud detection.
Sure.
Our source gave us this query, select accounted count as large transaction count from transactions where in thousand group by count is having large transaction count 1.
Right.
So how does that query help identify potential fraud?
So this one's designed to find accounts that have made more than one transaction
Okay.
above a certain amount, in this case, $10,000.
Okay.
That where amount 10,000 part filters out any transactions
Mhm.
that don't meet that criteria. Then the group by Y accounted bring those large transactions together based on the account.
Okay.
Now the key here is the having large transaction count 1 part.
Okay.
So having filters the results after the grouping.
Okay.
So it's saying out of all those accounts with large transactions,
Uh-huh.
Only show me the ones with more than one large transaction.
Okay, so where is like a
Yeah,
first filter,
right.
and then having is like a second filter after you've grouped things?
Exactly. Where acts on the individual records and having acts on the groups.
Okay, that's really helpful.
Yeah, it helps to keep the two distinct.
Okay, our source also talked about analyzing patient demographics using joins and aggregations,
Right.
but it only gave us the aggregation example select department, AVG age, as average from patients group by department.
Yeah.
Can you explain how joint operations would kind of expand the possibilities for that demographic analysis?
Sure. So that query you mentioned neatly calculates the average age of
Uh,
patients in different departments.
Um.
But joins unlock a whole new level of demographic insights.
Okay.
Imagine you have basic patient info,
Okay.
like name, age, diagnosis,
Huh.
in one table.
Okay.
Then you have more detailed demographic data like ethnicity or insurance provider
Okay.
in a separate table.
Okay.
A join clause can connect these tables
Okay.
based on a shared identifier like a patient ID.
Okay.
Once they're linked, you can aggregate across the combined data.
Okay.
For instance, you could analyze the average length of stay
Right.
for patients of a specific ethnic group
Okay.
with a particular insurance plan.
So joins are like these bridges that let you bring data together.
Exactly.
Okay, now let's think about that online store database again.
Yeah.
If we were the analysts, what are some SQL queries we could run
Sure.
to answer real business questions?
Well, one question any retailer wants to know
Yeah.
is, what are our best-selling products?
Okay.
You can answer that with this SQL query.
Okay.
Select producted, ACM amount as total sales from orders grouped by Y producted.
Okay.
This gives you a ranked list of your products by total revenue generated.
Sure.
And that informs inventory decisions,
Right.
marketing campaigns,
Right.
even product development.
Okay, that makes sense. What about if we wanted to understand our most valuable customers?
Right. Well, to really understand customer value,
Uh-huh.
you want to calculate their lifetime value,
Okay.
the total they've spent over their entire history with your store.
Right. Okay.
The SQL query for that would be
Okay.
select customer, AEC,
Mm-hmm.
CMIA amount as lifetime value from orders grouped by customer order by lifetime value, DESKey limit 10.
Okay, so we're summing up all the purchases again for each customer.
The order by orders ranks them from highest to lowest lifetime value,
Right.
and limit 10 restricts the output to just your top 10.
Okay, so that's incredibly useful.
It helps focus resources on those high-value customers
Right.
to maximize impact.
Okay, and just to reiterate for that fraud detection, the query we looked at earlier, select accounted count as large transaction count from transactions where amount 10,000 group by accounted having large transaction count 1, that would still apply here for the online store.
Absolutely. Those SQL queries directly address those key business needs.
Yeah.
They provide data-driven answers about product performance,
Right.
customer value,
Huh?
and financial risks.
Okay, so we're really seeing that power and practicality of SQL here.
Yeah, SQL goes beyond theory.
Yeah.
It's a tool for driving real-world business impact.
Okay, our source also had these interview-style questions
Right.
designed to test understanding.
Yes.
Let's tackle a few of those now. First up,
Okay.
how would you calculate total sales for each customer?
The SQL answer is select customer, SUM amount, as total sales from orders grouped by customer ID.
Okay.
It demonstrates how to aggregate data based on a group.
Okay, next question.
Yeah.
How would you find the most common diagnosis in a hospital?
The query for that would be select diagnosis count as diagnosis count from patients group by diagnosis, order by diagnosis count, DSC.
So that's about counting occurrences
Exactly.
and then ordering to find the most frequent.
Precise.
Okay, last question.
Okay.
How would you detect accounts with multiple large transactions?
The query is select accounted count as a large transaction count from transactions where amount 10,000 group by accounted having large transaction count 1.
Okay, and that tests how well you understand filtering before and after grouping?
Exactly.
Yeah.
It shows if someone can take a real-world problem
Uh,
and turn it into a SQL solution.
okay, now let's move to the scenario-based challenges that our source presented.
Yeah.
So first one, how would you calculate the average order value for an e-commerce store?
You'd use the AVG function.
Okay.
So the query would be
Okay.
select AVG amount as average order value from orders.
Okay.
This gives you the average amount spent per transaction.
Okay.
It's crucial for understanding spending patterns and pricing strategies.
Scenario 2.
Okay.
How would you find patients admitted in the last month?
You'd need to filter by date. So the query would be something like select from patients where admission date, date sub, current date, interval 1 month.
Okay.
Now, the exact date function might vary a bit
Okay.
depending on the database system, but the concept of filtering based on the current date is the same.
Okay.
The key is that SQL can work with temporal data.
Okay. And last scenario,
Okay.
how would you calculate the running total of revenue?
We'd use a window function like before.
Okay.
So the query is select order date revenue, SEM revenue over order by order date as running total from orders.
Okay, so this is showing that you can perform those
Yeah.
cumulative calculations.
Uh-huh.
These scenarios really show how adaptable SQL is.
It's a really versatile tool that
Yeah.
can be applied to all sorts of analytical tasks.
So as we wrap up this deep dive, I think the main takeaway is
Yeah.
SQL is so much more than just a language you learn in a textbook.
Absolutely. It's
Yeah.
a practical and powerful tool
Yeah.
used to solve real problems
Right.
across industries.
From basic data retrieval
Ah.
to complex analyses that inform big decisions,
Exactly.
SQL is kind of the engine that runs our data-driven world.
And in future deep dives,
Yeah.
we could explore areas like SQL interview prep
Oh, that's a good idea.
to really solidify that real-world understanding.
Yeah. And for you listening, take a moment and think about your own interests,
Uh-huh.
your own professional life. Where is data being generated?
Right.
What questions could be asked if
Yeah.
you could harness that data and analyze it using SQL?
Think about the vast amounts of data that are out there just waiting to be explored.
Yeah.
Tools like SQL
Yeah.
give us the power to unlock that knowledge
Right.
and to make better decisions.
What questions could you begin to answer?
It's an exciting prospect to consider.
Yeah, it really is.
Yeah.
Okay, well, thanks for joining us for the deep dive.
Thanks for having me.